session in what I'm calling super tech. Super tech are the complementary technologies that radically amplify the value of the Internet of Things. And today, in this session, we're taking to the skies. So we're starting with drones. Urli is the Director of Flight Operations for Airrobotics, as well as serving as the President of the ACUO, that is the peak body for commercial drone operators. How long has that been around?
It's been around for 7 years.
7 years? Wow. And he also sits on the Director's Advisory Panel for CASA. Make sure that the drones stay where they should and the planes stay where they should. Please, let's welcome Urli.
Good afternoon. Thank you for the opportunity to speak here today. I want to share a little bit of insight into my world of aviation and the convergence between IoT and aerospace. Very excited to be here. The company I represent is Airbotics. It's an Israeli startup company. It's just been around for a couple of years, and just give you a bit of background into the company before I get into the technical aspects of Airborne IoT. And speaking of which, the cloud has a totally different meaning in this context. Sorry, I think I just went a bit too quickly there. So let's go back a bit. Okay, so Airrobotics was founded in 2014. It has about 150 employees and has 3 sites, 2 in Israel and 1 in Western Australia, Perth. It's managed to raise $61 million in funding and is growing by the day. If you look at traditional drones for services, you have an operator. This is the pilot, the controller of the drone. This person turns up at a site, could be either be a contractor with their equipment, and performs a service. This is what traditionally, this is what most people perceive as a drone service. Most companies started off also by training people in-house and absorbing those costs and getting operators or employees to actually fly drones, making them pilots. But there was a big sector of this that was missing. Drones are normally associated with dull, dirty, and dangerous. You don't want to expose employees to that type of environment, so there was a need for automation. Automation was something that was on Airrobotics' design plan, and we looked at what are the shortcomings of an operator or drone pilot. Number 1, a drone pilot is very expensive to hire for a day. If you have routine missions that need to be flown, taking this person and exposing them to a weekly or daily routine of 10 or 20 missions is very cumbersome and time-consuming. Second one is accuracy and precision. Computers are far more accurate than humans, and they don't get tired. So that was one factor that we realized that the shortcomings of an operator didn't have. The next one was on demand. Even if you had a drone operator on the side with a drone, from the time you need intelligence or eyes on the scene, it'll take 15 minutes to get the drone airborne. If you have a solution that's automated on the site and on demand, you're halfway there. So just looking at how drones started off, specifically consumer-grade drones, they started off as toys. And as things progressed, toys started turning up in work sites. So we started to notice a lot of toys turning up in industrial facilities. And so how do you change a toy into a drone? And so looking at, I think somebody's hacked my little beeper here. Just going back a slide. To turn a toy into an industrial grade tool take a lot of insight. And part of the designing team in Israel, we looked at obviously trying to get through the different aspects very quickly, looking at something that is self-sufficient. When you're on a mine site, you need your own power supply, you need something that's self-contained. You need something that's highly automated and permanently on site, and possibly the most effective tool on the site. So fulfilling the vision of having an industrial grade drone, we had to create an environment so the drone could land back in a box, and the whole concept of a drone in a box came out, where you would position the airbase at a particular site. It'll be self-contained, and you'd have all the things that a normal operator would do, like changing the batteries or the sensor payloads. This is our system. So there you have it, a drone in a box, completing the automation cycle, something that is on the cutting edge and that's never been done before at industrial level, at industrial grade. So just to recap, so you have the DSA, the docking station. It's the tiny airbase. It has a robotic arm that changes out all the batteries and sensor payloads depending on the mission. You could change between a security mission or a volumetric assessment mission, all integrated. You have the mast for your C2 downlinks, so communicating with the Optimus drone, which is an industrial grade drone that captures all the data. And you have the intuitive software. This was all designed from grassroots, from the ground up. So Airrobotics took a deep analysis on certain markets, and we found the high-value markets being oil and gas, mining, power plants, paper mills, and other areas that we wanted to apply this technology. Everything had to be developed in-house, the software. We had the electrical engineers, mechanical engineers, and software engineers developed everything from scratch. We had to build an industrial-grade drone from nothing. And so with the innovation from the Israeli chamber, we managed to get all the different types of components together and build the robotic arm, the airframe of the drone, and put it all together in one package. So looking at the data collection cycle, and this is what we're talking about today, is this data collection. We have the airbase with the robotic arm. We have takeoff. The drone gets airborne, goes over and senses and acquires data from different sites, and it lands back in the box with the servers downloading all the information. That information can be relayed into the cloud or as the local area network is configured. Then it's basically fly, start, repeat. There's a picture of the robotic arm changing out the sensor payloads and the batteries from within the airbase. It is fully automated and highly accurate. All the telemetry is provided to the system operator at the remote operation center who can track it. Some of our clients include South32, ICL, Israeli Chemicals, and Intel. At these sites, South32 was the first site in Australia, the first footprint outside Israel, where Airrobotics was basically setting up operations and getting also certification through CASA for beyond visual line of sight operations. Part of the test facility was obviously an important part of the R&D. And this test facility in Israel is probably one of the best facilities for abuse testing the drones, having reliability, looking at atmospherics, looking at rain, dust, and 24/7 day-night operations. This test facility is one of the most advanced facilities I've visited myself, and very proud to show you a little insight to the facility. So we chose levels of maturity. How do we introduce this technology into industrial environments? Like software, levels of maturity are very important. We had to look at remote areas, we had to look at low population density, and we have our runs on the board. So we looked at industrial facilities like oil and gas and mining. Those types of environments, coupled with homeland security, provide the best platform in certain circumstances to acquire data. These types of operations were based on the levels of maturity, and slowly but surely what you're seeing today is a tendency of people moving towards a level 3 or level 4 tier of maturity where you can safely use drones for emergency situations of fire, first responders, and all sorts of environments that require eyes on the scene. In terms of designing cities and smart planning, looking at how we can incorporate an airbase or a system that would allow eyes on the scene or delivery system, which is the next level of maturity. So what you're probably looking at today nowadays is more the commercial delivery. This is in populous areas. This is something that the Civil Aviation Safety Authority and different regulators around the world are looking at in terms of airworthiness of drones, the reliability, the robustness, the airworthiness aspects of those drones. In a city situation, how nice would it be to go do grocery shopping with your drone and send a drone out and it could deliver your groceries at a particular pickup point on a building and to your doorstep. I'll leave you with a sight of the future. Picture paints 1,000 words. Thank you very much.